So hello everybody. Good morning. I hope everyone is well. So we're back to chapter 5, and I'm making part 4 now. We left off. We were talking about. We left off here with this little blurb about a truck driver and how lotto works. And I want to continue. So here is what's known as a perpetuity, and that's an important word. I'll highlight that. All right. And basically, we're going to find the present value of a perpetuity. Now, a perpetuity is just like it sounds, perpetual, meaning it goes on forever. It's an annuity with an infinite life, right? So, we'll highlight that. That's important. All right. And basically, what it simply says is, if I have money in the bank, some lump sum that I put in the bank, okay? Let's say you have $1 million in the bank and you get 5% interest every year, right? So 5% of $1 million is $50,000, and I could take that $50,000 out every year, right, and live on it, and leave the million in, and I could do this every year if I could guarantee myself for 5% interest every year. So here's the equation. So here's that cash flow of 50,000 divided by the 5% interest rate, and that gives us the $1 million present value. It's kind of like what colleges do with endowments, right? They have money in there and they draw money on the endowments. So this is the this is the equation we got to worry about right here, right? All right. So move on now. So it's a simple equation. The math is trivial. So here's an example of an endowment, right? Just as I said with colleges, someone wants to endow a chair, right? So it's a simple concept. Okay, so you'll notice the term here, mixed stream. So we have the future value of a mixed stream. And you'll notice the mixed stream is a bunch of cash flows, but they're all different. They're all mixed up, right? So the magic word here is mixed, right? So we have this mixed stream. So the question is, how do you get the future value of a mixed stream? And they show you exactly how to do it. You do one year at a time, blah, 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 5 years, 4 years, 3 years, 2 years. And obviously this is the end of the 5th year, so it doesn't grow, right? So this is the future value, and you add them all up. This is how you get the future value of a mixed stream. If you have any questions on that, just email me. And here's how you do it in Excel. Here's the present value of a mixed stream. We just go the other way now, right? We're going the other way. Back to the present, and again we just take them and we add up. We just add these up. So here's how you do that in Excel. And all right, so now we have come to compounding more frequently than annually. As you know, banks give you interest, right? They compound it, so you end up getting interest on interest, and that ends up giving you an effectively higher interest rate, right? And the magic word there is effective. So right here you see the effective interest rate, and they say it's greater than your nominal, right? You've all been through this with banks, right? Because you'll get, like, even though interest rates are so low, you'll get an extra penny or two with these interest rates. All right, so you can clearly see here, here's the interest on interest. Instead of just having $108, right, getting $4 the next six months, you get an extra 16 cents. You're getting interest on interest if you follow this carefully. All right, and basically they go through this for 3-month periods, so you can see the interest growing or compounding more than you normally would without compounding, right? And they show you this example over 2 years, right? All right, so here's the comparison, right? 108 semi-annual is 10816. So you can see the more compounding, the amount more, the greater the amount of money you get, right? That shouldn't be a surprise to anybody. All right, so this is an important equation. So I'm gonna highlight this, right? So this guy here tells you the future value of some lump sum, right? And it's basically 1 plus the interest rate divided by the number of compounding periods. And you'll notice here they take the number of compounding periods and multiply it by the number of years, m times n. So they show you an example down here of what we calculated before, right? So here's the $100 principal or present value, and semi-annual is the 2 and 2 years. Quarterly is 4 periods. Okay, so you go through all that, and here's how they do it in Microsoft Excel. And I'm sorry, but this is with a calculator here, and this is Microsoft Excel, and they show you how they get the numbers. So you could practice this, and here's the equations, right? Here's the equation right here. All right, now what happens in a theoretical sense if money was compounded all the time, continuously, right? Here's the future value, here's the present value, and you use the function called the exponential function. And that's important to know, and that's built into Microsoft Excel. So if you go to Microsoft Excel, you would find a function called EXP, and all you do is multiply the R times N together in a cell, and then just pop it in the EXP function in Excel, and this will give you continuous compounding. All right, here's the present value, and that's all you have to do. And I believe there's an example in so here's an example of continuous compounding. Every once in a while I got to take a coffee break here, if you don't mind. So they show you how to do continuous compound, and this is the E is continuous compounding to the first power. So but again, you just pop this into your calculator or the or Excel, and I believe yeah, they show it to you right here. Yeah, you can see, right, EXP, the EXP function, and that goes on now that way. All right, so how do you calculate that effective interest rate we talked about? And again, it's a similar equation. It's called the effective annual rate, and you have the number of compounding periods. And this is the annual effective annual rate, EAR, right? And this is greater than the nominal rate, right? So if this is 1, obviously the effective rate is equal to the nominal rate, right? So this will give you that. And you see the sign in the banks all the time telling you what your effective yield is. So here's some examples of that. And we're going to kind of skip over ethics, right? Because, you know, well, it's good to read because they tell you how much you get ripped off with payday loans and stuff and crooks and everything. And obviously you can look up a lot of this stuff on Google if you want to read about payday loans and why they're crooks. All right, so here's an example. Here's an equation for getting if you have the sum you want, and you want to know how much you have to put in there to calculate a future sum. So this is the cash payment. So this equation calculates the annual cash payment that we'd have to save to achieve a future value. So it's, you know, this is a good equation to know about, right? And I have a nice example right here. So again, any questions, just let me know. Here's the payment function. In Excel, it's called the payment function. See it right there? So they go through that. All right, and this is about loan payments, right? To provide a lender with a specified interest return. So this following equation calculates the equal periodic loan payments necessary to provide a lender with a specified interest return and to repay the loan principal over a specified period. So they give you a nice equation here. So if you're going to borrow $6,000 over 4 years, as they show, you have to pay back $1,892.82. And here's the Excel version of that. And they show some stuff here. Alright, so I'll stop here and we'll pick this up on part 5. There's a lot of content here, so I want to break it into different parts. Alright? You can, work at your own pace if you feel I'm a little slow with these videos. Alrighty, we'll pick it up again. Take care.